Have you ever wondered why a bird can just sit on a high voltage wire totally fine? Or how a car can be one of the safest places to be during a lightning storm? Well, we're about to dive into the single physics concept that explains it all.
So let's kick things off with a few everyday puzzles that, they might seem like magic, but they're actually pure physics.
I mean, we see it all the time, right? Birds just chilling on wires carrying thousands and thousands of volts. For us, a faulty wire at home is a huge danger. So what's their secret? Why are they completely fine?
And then there's this one. You've probably heard that a car is one of the safest places to be in a thunderstorm. But really, how can a big metal box actually protect you from a lightning bolt that powerful? It kind of feels like it shouldn't work, right? Okay, so here's where it gets really interesting. What if I told you that the answer to both of those mysteries also explains how a hospital ECG can read a heartbeat? What on earth is the connection there?
Well, the answer to all of these questions, it all comes down to one core concept in physics, electrostatic potential.
So you can think of it as the electrical power or strength that a charge has just because of where it is in space. But, and this is a really big but.
Yeah, check this out. This is a key insight from the source material. It says, according to physics, electrostatic potential is not defined. Electrostatic potential difference is. So what does that even mean? It means that the potential at a single point, by itself, is basically meaningless. What actually matters is the difference in potential between two different points.
Right? So this difference, that's what actually does the work. It's the driving force. It's kind of like how water only flows downhill, right? It needs a difference in height. Well, electric current is the same way. It only flows when there's a potential difference, what we usually call voltage.
Okay, so we've got this idea of potential. But how does it connect to the electric field, which we've talked about before as the actual force electricity exerts? Let's break that down.
And this slide really lays it out perfectly. The electric field, that's the actual push a charge feels. It has a direction, and it gets weak super quickly as you move away. Potential, on the other hand, isn't a push. It's more like the underlying strength of the location itself. It has no direction, and its influence fades out much more slowly. All right, now that we have this key idea, potential difference, let's go back and finally solve those mysteries we started with.
Okay, first up, the bird on the wire. Why is it safe?
And the answer is surprisingly simple. There's just no potential difference. See, both of the bird's feet are sitting on the exact same wire, which means they're at the exact same high potential. Since there's no electrical hill for the current to flow down across the bird's body, it just ignores the bird entirely and keeps right on moving along the wire. Simple as that.
Next up, the car in the lightning storm. And a lot of people think it's the rubber tires that protect you, but that's not actually the real reason at all.
The real hero here is the car's metal body. It acts like a perfect shield. When lightning strikes, that massive charge spreads out instantly and evenly across the entire outer surface. That means the potential is the same everywhere on the outside. And if there's no potential difference across you inside the car, the electricity has no path. It just flows around the metal shell and safely into the ground, leaving you completely untouched.
And finally, the ECG machine. Now, this might seem like it's from a totally different world, but it is operating on the exact same principle.
You see, every single time your heart beats, it creates this tiny, measurable electrical ripple that spreads across your chest. The ECG machine is incredibly sensitive. It's not measuring some massive voltage. It's just detecting those tiny changes in potential on your skin to create a map of your heart's health. It's all about the difference.
Okay, so we've seen how potential difference gets electricity to move and how we can measure it. But what if we want to, save it, store that energy for later?
So, can we actually bottle up this electrical strength and use it exactly when we need it? The answer is a huge yes, and it's something we do literally all the time.
And this is where a concept called capacitance comes into play. It's basically the ability of a system to store an electric charge. And we do it using these incredibly useful little devices called capacitors, which are kind of like tiny electrical storage tanks. And you find them everywhere. They are the absolute unsung heroes of electronics. They store up energy and then release it in a quick burst. That's what provides the big jolt to get a ceiling fan spinning, or the power for your camera's flash. They're even managing all the tiny, precise operations inside your phone. They're in almost everything.
So, from a bird on a wire to the beating of our own hearts, it's all governed by one simple rule: Electricity only flows when there's a difference. It really proves that in physics, and maybe in life too, it's not about some absolute strength you have, but it's the contrast, the difference between 2 points that truly creates power. Thank you for watching.